Hello, good afternoon, everyone. You're welcome to today's class. Today, we are going to be calculating the loadings on the beams. In our last class, I told everyone how slab, how they transfer their load to the beams. All right. Now, for a two-way spanning slab, this is the arrangement. This is the arrangement. Then, for a one-way spanning slab, it's like this: half of the load will transfer to the beam along the longer span. All right. Now, I said before, this is a trapezoidal shape transferring the load to the longer span. While this is a triangular shape transferring the load to the shorter span. Now, the dimension of this beam is shown, the board. But again, we are not going to be making use of this dimension because this is the dimension between wall and this wall, all right? Between these walls, between the walls. Now, if you want to the dimension we use now is this clear span plus the thickness of the wall. That is, for instance, we have this is the beam. We are working on the one now. This is one here. This is another dimension. So if you want to now dimension this beam is 225, the thickness of the wall plus the dimension, which is 2250. And this one, this 3887.5 plus 2250 will give you 4112.5 in millimeters. This one will also give you 4112.5 all in millimeters. Okay, this is what we're going to be working with. All right. Now, how are we going to get the loadings on this particular beam? Recall that the beam has its own weight. Now, if we want to calculate the weight on the beam load, call it beam load is equals to, what is the section of this beam? The beam is 225 by 450. All right, 450 as shown here. Now, the load on this beam is 0.025 multiplied by 0.450 multiplied by concrete density of concrete is 24. Then it's a dead load. The beam is a dead load multiplied by the factor, which is equals to, when you compute this, you are going to have, let me calculate this, 225.225 multiplied by 0.45 multiplied by 24 multiplied by 1.4. This one will give me 3.4 kilonewton per meter. All right. Now, what about beam finishes as well? Beam finishes, you can, let me make it 1.20. All right, 1.20. So by the time you add, you're going to have 4.60 kilonewton per meter. Let's approximately say 5.0 kilonewton per meter. That's beam on load. All right. Now, what about let's call this one beam load. Beam load. All right. That's the beam load. What about the slab load? Slab load. This is along the shorter span. All right. There's a formula to calculate the loading from the slab here. The formula is, let's say, slab load on beam is equal to 1/3 multiplied by W multiplied by Lx. Now, this is the formula for this shape, for the shorter span. All right, for the longer span, it's a different formula entirely. So the Lx now is now 4112.5. Recall that the Ly is along the longer span, which is, if you now add 225 to this, you now make it 4425. All right, this one becomes your Ly. So we always make use of the shorter span. Okay, so when you impute the values, now say that 1/3 multiplied by, this is our UDL. If you have been following my class, one of the classes we calculated and got a value for our UDL. Our UDL is 14.52 multiplied by LS 4.1125. All right. Okay, let me make it so that it is uniform. As equal to 1/3 multiplied by 14.52 multiplied by 4.1125. This one will give me 19.90 kilonewton per meter. All right. Now we also talk about wall load. Now the clear height between walls, in our previous classes, we said the clear height between walls is equals to 3.3. All right, is equals to the height 3.3 meters multiplied by the weight of one block is 3.47. Remember, the weight of one block, when we are talking about one block, this is 225 block. All right, when you are making use of 150 mm, that becomes 2.87. all right, this is 3.47 now. All right, so we now multiply by, it's a dead load 1.4. okay, this one will now be equal to, when we compute this, we are going to have 3.3 multiplied by 3.47 multiplied by 1.4. This one will give me 16, approximately 16. Okay, let's say 16.03 kilonewton per meter. All right. Now, when you calculate this load, you remember we are solving for this and this now. All right. We already know the weight of our wall to be this, the weight of our slab to be this, the weight of our beam to be this, for only this and this. This one is a one-way slab. So this one-way slab, we are only going to make use of the UDL, which is 14.5, plus the wall load, which is this, plus the beam load, which is 5 kilonewton per meter. So when you now add all this together for these beams, we are now going to have when we add all these things together, we are going to have plus 19.90 plus 5. This is equal to 40.93 kilonewton per meter. All right, that will now be the load on this beam and this beam. We are still coming to calculate for this because they cannot share equal loads. All right, so this is 40.93. all right, now we can now come to this other beam, Let me clean. Let me clean. Then let me call this one beam 1, beam 2, beam 3. Alright? Let me say beam 1 now. Beam 1. Alright? Or span 1. Span 1. Span 1. The load on the from the slab load is equals to 14.52 kilonewton per meter. Alright? Then beam load as calculated is equals to what? 5.00 kilonewton per meter. Then wall load is equals to, wall load as calculated is equals to 16.03 kilonewton per meter. So if you add this together, I'm going to have 14.52 plus 5 plus 16.03. This gives me 35.55. 35.55 kilonewton per meter. Alright? So we have been able to calculate loading on span 1, span 2, span 3. So let me now represent it in the diagram. Right? So it's not going to be like this in the diagram. I'm not going to have something like this. I will now call this one 35.55 kilonewton per meter. Then we'll now call this one 40.93 kilonewton per meter. So that is how to calculate the loads on beams. Alright, recall that this one is 2250 411 2.5 411 2.5. So this is the load on the beams. Okay, this is a smaller load. This is a lesser load compared to this one, because if you even check the span from here to here, see the span. Okay, this is the other span. So that is where we are ending today. In our next class, we will now go and be designing. We will now go and design for the slab to now know the reinforcement to be used. Thank you and God bless you. We see you in the next class. Thank you.